I'm getting started on the Denon DR-M44, and the first thing I need to do is remove the transport. I've got quite a few screws here and a whole lot of connectors. This is the deck that I'm building the ebony side panels for, and they're coming along nicely. I did those first so that I could get plenty of finishing time on them and be ready when the deck's ready. This deck will get a full rebuild. I really like the sound of it when I first tested it out, even without any sort of work done on it at all. It had a very nice musical sound to it, and I don't want to change that. I want to quiet it up a little bit, enhance it, but I really like the character of it. And so first in the process is the transport, and it was functioning fine. Of course, we'll do a complete rebuild on it, not just belts and or a belt. Boy, this thing really has a lot of kind of a rat's nest here, the way they wrapped everything around. We'll clean that up when it goes back together. I put a W there to remind me that the washer goes on that spot. A lot of these connectors are interchangeable, and so I'm being careful to mark their positions so that I don't have to go back and debug it because I put the wrong connectors or interchange the connectors. But yeah, it has plenty of them. I don't like to pull on wires, obviously. I like to use a good set of needle nose on the connector itself and just wiggle it. Denon used some nice heavy-duty cabling in here, and I like the way they did that. In a lot of decks, they'll use very thin wires, and after a few years, you'll have problems with the solder joints just because the wires are thin. These are much thicker, and the soldering looks really good in here, or soldering, however you like it. Just using Sharpie paint markers. Wow, they just really unbelievable. I have to remove this daughter board. two little clips, and it pulls right out. I'm liking the traces. They have nice wide traces. They're not silk thickness like some of them are. I personally believe that contributes to better sound. Okay, finally. Wow, that was quite an ordeal. And I still got a rat's nest. This is my first good look at the heads and pinch rollers. I believe that I might have problems with the record head on this one, but I'm not sure. I've got to clean it up and give it a try again, and it may end up being okay. But I got a parts deck in case I do need a new head for it. I'm still hopeful that this one will be okay. It's nice and clean. There's a little bit of residue there on the little belt residue on the capstan pulleys. Not bad. Still got a little springiness in the belt. I have no doubt this is a factory belt. Kind of tell by the screws that it hasn't been into before. This is operating very smoothly. I like the way the head block works. There's nothing in there that would indicate contamination or debris. Another look at the heads. And just eyeballing it with my magnifiers on, it looks like it's just the very start of normal wear. So hopefully that will be just fine with a good polish. Maybe I'll have to lap them a little bit. Grease is still liquid. It's not hardened up. That's a good sign. From what I've seen, Denon actually did use a little bit higher quality grease in their decks. I don't think I've seen one that's had dried grease problems. Look at these little oil stoppers off. Now this capstan has the dull finish on the take-up side, and you can see just a little, again, the same thing, just the beginnings of a little bit of wear, normal wear, and I'll just have to decide what to do with that. I may mask it off and re-sandblast that tip, or not sandblast, but bead blast. And that will require the getting some of the finer bead material than what I actually have here. And that's fine. I'll use that. It looks pretty good. Quite a bit going on in this transport, but they're well made. And right there, you can see one of the problems with the overmolded posts. Just removing that broke that. And I'll be dealing with all that coming up here in a few minutes. Overmolding is an incredible process and it's very efficient, but it does leave some issues like this. Everything's free, nothing's bound up. I've got my pin gauges out here and I want to test the capstan bearings and see what kind of wear I have in those. I'll try a 097. That's loose. 098's loose. And it looks like 99 thousandths hit the jackpot. Of course, these are oil impregnated sintered bronze bearings, and so I expect to have a little bit of resistance there, but not as much if I were in a piece of steel or something like that with more friction. But there's good resistance there, and I'm pushing that down and I can feel it capturing the other bearing in the back. Really no play in there, no movement. So I'm not elliptical in the bearing, which is good, of course. Yeah, there's definitely resistance, about what I'd expect. On the supply side, almost identical, same feel. So I'm calling that 99, and I'm looking up the clearance on that size of bushing to bore to shaft, and everything I'm seeing is coming up with anywhere from 1/2 thousandth to 1,000th for a running fit. The one SAE manual showed 4/10ths or 4/10,000ths to 1,000th and 4/10ths. And so let's just make sure that my 99 pin is 99, and it is. Always want to double check whatever pin I'm using, because sometimes they get put in the wrong spot. Using Kim wipes here, not paper towels or anything like that. Of course, paper towels will shed debris, lint. Okay, let's measure our capstan shaft. Looks like I'm getting 0.98 and maybe 3/10ths or 3/10,000ths. I'm just going to call them tenths because that's the custom here. But when I say that, I'm talking about 10,000ths. And just trying to hit where the bearing is. And that's 0.98, and again maybe 2 to 3/10ths. Just double check all these, measure them in different spots, and I end up pretty much with 98 thousandths and 2 to 3/10ths on pretty much every place I measured. So that's giving me a clearance of 7 to 8 10,000ths, which is right in the cusp of the allowable clearance, right in the middle of it. So I'm good with that. That makes me happy. These bearings are serviceable, and I can do those here if I need to. But I don't need to on this one. Yeah, we'll just make sure that the backside of those bearings is similar to the front and equal to them. I'm trying to zoom in and kind of show what I can show you what I'm seeing. I can't show you what I'm feeling, but there is correct resistance and no rocking. And I can also see that there's no elongation anywhere. So these are in good shape. And it really is important on this style of deck. Okay, being satisfied with that, we'll change the idler tire. This idler tire is intact, but it's very hard and lasted a good long time. So it looks to me like they used pretty good components in this deck. They used good quality products. The ones I got for this seem to be a little thicker. Quite a bit thicker, actually. The cover on, I mean, with the plastic, it's, 25 thousandths oversized, even taking the cover thickness out. So I'll try it anyway, but I don't think they're actually going to work. I'm just going to throw a little IPA on here just to get myself a little better grip on the old tire. And just pull them off like that. No tools needed. Yeah, it even feels thicker. I'm not too confident on this. Yeah, that's a full 25 thousandths thicker than what I need, and that's not going to work. So that puts a little delay in things. I'll have to find another source and get the right tires. So now I need to deal with something that's common in some of our most beloved decks, and that's the overmolding gates and runners. These little stringy pieces of plastic that are prevalent in a lot of decks. They get loose like this, and they break off and get into the components. And this is an amazing process. It's wonderful to watch it being done, especially if you do it correctly and remove the runners. The options are to be left alone, which I can't do that, to glue them down with RTV, and there's the problem right there. It just doesn't take anything at all to break them off. The RTV I won't do, and so the other option is remove them. And then there's no chance they'll ever break off and gum up the works. Move that cam follower. You can see I repaired the one on the screw stud, and the rest of them is off with their heads. Couple under the motor I need to get to, and the cam. The repair on that one was using Loctite, what number was that? I want to say 491, but I'm not 100% sure. It is the rubber reinforced, I think they call it, CA, and it's a good product all around. Clean that up a little bit. One more thing on these capstan bearings. These can be clocked in a different spot. They can be rotated. It's not the best solution. It's better to replace the bearings, but in a pinch, a guy could rotate them and get a little bit more life out of the deck. The thing that happens, the problem happens when they elongate, is that it skews the capstan shaft. It's no longer perpendicular to the tape, and so it's hard to get the tape to track correctly when the capstan is not, in proper alignment. That's the biggest problem. It's not eccentricity. They don't go eccentric because they've worn into a groove and they stay in that groove. And so the problem is tape skew. That's what ends up happening to those. All right, so I'll just go back here and I'll finish cutting off the little stubs that are left. And now I know I won't have any parts breaking off and getting into the mechanism. And clean up the cam. This is again, just another really well-made part. Probably no chance of this ever cracking on its own. Of course, it won't ever be tight on the shaft. It will always have clearance. And that's where most of the problems happen with shrinking plastic on a steel shaft or metal shaft. But this has got clearance. And it's good thick plastic. It should be a good component. This, on the other hand, is a problem because this is a press fit on that shaft, and it will at some point crack. It's not a matter of if, it's just how long it will last. Fortunately, this is a part that could be easily remade. And it could be remade out of brass or something like that. I've got several of these that use the same component, and I'll probably measure these at some point just so I can have the ability to manufacture them if I need to, or when I need to. Let's get a little drop of oil in there. I'm just going to clean this out. There were no problems with it. Just give it a shot of cleaner. Run it through a few times. And I'll blow it out, and I'll follow up with some fader lube. I know there's a lot of discussion about using red D5 deoxit. My experience is the fader lube is the right product for carbon pots. And it was their opinion too. Now, did you see that little thing popping out of there that looks like it might have been some kind of a part right there? Yeah, well, that's not a part. That is a little beetle carcass or something. Now look, I know my hands are never going to win any contests, or I'll never be a hand model, but I am master of my domain, so there is that. So initially I thought that might have been an actual part of that potentiometer, but no, it's a little beetle carcass. All right, enough of that. So I go with fader lube. I don't use the red deoxit on pots or anything else. Lots of discussion about that, and this is my method. I'm going to put some of this back together, even though I'm waiting on the order of the idler tires, and I went ahead and ordered a gross of them so that I could make them available, assuming they're the right ones, and they should be. The measurements are correct. So if everything's okay on that, when I get them, I will put a link to their to the eBay page for them. And also put the reel motor back on. This is the follower for that cam, and right there on the tip, it's a little rough. I'm just going to clean it up. It's a steel follower that rides on a plastic cam, so I'm just polishing that up a little bit so it doesn't ever, try to scratch that plastic. It's all synthetic lubricant, should never need to be dealt with again. It should not dry up. Clean up the capstan pulleys. Kind of got to scrape that off. I'm going to mic the diameters on these just out of curiosity and just to have a reference. There is a difference in size between the two pulleys, and that creates the back tension. And I've seen a number of different diameter differences from 1/1000th of an inch on up. And so just, curiously looking at this for future reference, if I ever need to deal with one, if I ever need to machine something that's been damaged and can't be measured, whatever. So there we go. I'm going to do that one more time. I'm not really convinced I had, trying to keep everything in frame, and I am not doing this in the same position and orientation that I would do it normally. So I'm going to double check this because I'm not too sure about that last number. There we go. I think I got a good bead on it there. And what I'm seeing there is 2" 8/37 and about 7/10. Yeah, and I'll measure that a couple more times just to make sure. And this one I definitely have to do off camera because it's got a crown in it, and I cannot do this without really kind of holding it the way I need to hold it. You can see me kind of struggling trying to center on that crown. And turn it around, do it a different way. So after remeasuring everything in my normal way, I came up with 2" 8/37 and 3/10 on the take-up pulley, and 2" 8/41 and 6/10 on this one. That's where I ended up. And using the calculator at blocklayer.com and punching in those numbers, I came up with, at 450 RPM, the supply side turning at about 449 RPM, which back tension is providing, whatever that works out to be. Just a fun thing, just something to look at. Others I've kind of played around with, I've noticed somewhere around half an RPM or less. I'll just lubricate the back side. This is a nice reel motor, Canon, with open bearings on the back so both sides can be reached and lubricated. I'm just going to tape that thrust bearing in place and do a recap on the motor board. I've already got my cap selected. My procedure is to clean and form the leads. I don't like shoving them into holes and stressing them. And I did check these kind of a good habit. Don't really see too many bad capacitors, but every once in a while. Also like to scrub the pads. It's okay on newer components, I think, to just use the soldering or the desoldering station and remove the remainder of the solder. But on these vintage components that I always see, I like to scrub the pads. You never know if there's a little bit of oxidation underneath. And the solder wick with RA solder really does a nice job with that. Of course, it does have to be cleaned off. No Q-tips on this sort of thing. These are electronic swabs. Q-tips leave fibers behind, and I don't want contaminated joints. I'll start with that, scrub it off, and then I'll go back with a foam swab to make sure there's no fibers from the other swab. I also clinch my leads in the direction of the trace. The tool I'm using is just a piece of polycarbonate that I cut and shaped to do this job. Help me do it. The other thing I like to do when I have a number of components like this to solder or solder is to just do one leg of each in sequence and then go back and do the second leg. I believe that keeps the total amount of heat down on the components. And you can see spend very little time on that pad. Everything is clean, and so it doesn't require much. You know, it doesn't have to be super heated to get the solder to flow out. I clean it up with IPA a couple of times, blow it off, and then look for any problematic joints, anything like that. This one was in really good shape. No problems there at all. Just quickly check the coils, motor coils. Very nice. Clean the old grease out of the thrust bearings. And then reinstall or reapply with Krytox on this. This little foam has decomposed. I'm not sure what that does, but I don't want that debris falling off in the deck. So I'll clean that off, and then I'll mark it to remind me to check and see what it does when I put it back together. And if I need to replace it with a piece of felt or something, I can do that. That was on there pretty good. I'm fast forwarding through all this because I'm condensing over 3 hours of tape film and trying to keep it under an hour. I appreciate it when people say what they like in the video and what they don't, because there's a lot of editing that goes on and a lot of effort that goes on to do it this way. And so if you like the long format, you like the short format, I do appreciate knowing that. And if you just like it, I like to know that too. So I'm fast forwarding through much as I can and hoping that it's received well. Those little plastic washers I removed off the axle will probably be replaced with proper E-clip. What I first like to do on these pinch rollers is clean them with warm soapy water, Dawn soap, and a scrub brush, a very stiff bristle scrub brush. A lot of times they'll come right back to new. So I'll try that first, remove the pinch rollers from the brackets, and then give them a good scrubbing. Pop those out of there. Yeah, very high quality pinch rollers. I'm impressed with them. This is a brass wheel on a, it's not sintered bronze. This I think is an aluminum bronze or possibly silicone bronze hub. And I know that because when I oil them, it doesn't absorb into the bronze. So this is a very high quality pinch roller. Some of the highest ones I've seen on cassette decks, the better ones. So I did not get video of grinding them. They cleaned up nicely, but I could still feel like a hard coating on them. And so these will get precision ground. And I'm handheld here. I don't know how people hold a camera and work at the same time. I can't do it. I'm trying, but I'm just trying to show the run out. And this is the supply side wheel, the smaller one. It's got about a 0.5 of run out. Yeah, like I say, I didn't get an actual video of the grinding process, but I have videos of that. But I did take a couple of stills. Of course, this is the new setup that I did in the last video, or one of the past videos. They cleaned up just beautifully. It took about a 1,000th off is all. The take-up side actually had very little run out, less than 0.5 thousandth. It was pretty impressive. It just had a kind of like a I don't know how to describe it, a crust on the surface. It still had friction, but not even close to what it has now. Let's get the axles cleaned up, clean up the brackets. Thought I had something on my pliers there, but it wasn't. This one, you can see quite a bit of the dried oil. And that's really another indication of not silicone or not sintered bronze bearings. Don't generally see that on a sintered bronze bearing. They kind of scrape it off. So probably aluminum or silicone bronze. Very high quality. Now, what occurred to me in watching the video and editing it was that it may not be apparent that there is a small and a large diameter on the brackets, and that pin, the axle for the pinch rollers, goes in and comes out only in one direction. And I'll show that here. In just a second. Like I said, these axles are straight and they will go in only one direction. Try to get it focused. So it'll easily slide in the one side and won't slide in the other side because that bore is a little bit smaller and it's an interference fit. That's what locks the axle in place. But it's important not to push when the tire is removed. When the roller is removed, it's important not to push it out that direction because you'll destroy the locking feature. Now, how do I know which is which when I take them apart? I can't explain it. I just know. I've been doing this many years and I can just tell which is the side to pull it out from. And, you know, one way is if you tap on it a little bit and it doesn't want to move, that's an indication. It shouldn't be much force needed to remove that pin. So that's how those work. I know I neglected to kind of mention that when I took these out, and I've done it many times, just not even thinking that it might not be apparent. That's what I'm doing. So there it is. Just show you that the pin is actually straight, not tapered. Of course, you wouldn't want a tapered pin. That would skew the pinch roller. It would skew the rotation. This is going to be a good stopping point for me on this video because I'm waiting for the replacement idler tires. And as soon as I get those, then I'll continue on with part 2. But I'm going to stop this one here. It's almost an hour long, and I think that's about most people can tolerate. So here we are. We'll continue on the next one. I thank you for watching, and I hope there was something valuable in this video. See you next time.